Okay, this is my poster for my smart monitoring system for precision farming for hydroponic. First of all, I want to describe about my project description. Um, First, smart monitoring system for hydroponic farming. Then we can monitor through light sensor, temperature sensor, and also ultrasonic. And able to control hydroponic solution pump by using phone with internet connection. The Blink app will notify low light intensity and high temperature. The Blink app also will notify hydroponic solution shortage and light intensity temperature of hydroponic solution. Second is my objective. The development of the set of general power supply model for the MV militia distribution network for efficient analysis currents at system scale in TL. Build an energy flow model of the radial MV distribution network to efficiently estimate the energy flow distribution in each major component in the network as a function 10 actual energy recorded at the TDIS, mass energy and peak demand from the MV feeder. Efficient methodology to estimate the system-wide TL of the EFM-based MV distribution network using RF modeling. My methodology will be the purpose of this project is to control and monitor the hydroponic system in real time. The purpose of this work was developed by a real-time monitoring and control system that would operate wirelessly using the Blink app applications. They'll describe all the procedures, methods, and techniques used to develop the proposed discussion of data collections. My problem statement: extreme hot weather climate in all over the world, deforestations, burning fossil fuels, increase in carbon dioxide gas contributes global warming. Planting more trees as well as forest reserves and rain catchment areas to be maintained so the local temperature can be reduced. People do not have time to supervise their gardens on their daily basis. So the idea of this project to develop the system that would allow people to monitor the water and nutrition in their garden using the web server accessible over the internet. Then my result and analysis will be the ultrasonic sensor operate with the condition 0 and 1 for the operation of the water pump. The waterproof temperature sensor measures the temperature inside the body of water. The data that's sent to the Blink app via Wi-Fi module ever wireless. This Blink app will visualize the temperature outside and inside the plant in real time. The Arduino microcontroller is used to control the entire operating system. The set point is desired water level and plant control temperature. The required water level set by the ultrasonic within the 0.15 meter and then monitor at the center at the set temperature of 28 Celsius and 38 Celsius. Then the information came to the Arduino. The with sensor, the feedback is an actuator based in feedback motion designed to achieve the desired measurement. After discovering the ultrasonic sensor, it will send the data through the Blink app, Blink cloud, and display the data through the Blink app. When the high temperatures are detected, an alert message will display on the smartphone screen to inform the user to take actions. The behavior is monitored by the water pump and LDR sensor that monitor water level and temperature. As a conclusion, in this work, he presented an alarm system for monitoring water and plant nutrition using IoT technology. In the first part, the outlines the steps required to create a decision support system for agriculture community that estimate the amount of water needed. Hydroponic is a method of growing hydroponic without soil. Instead of using the soil to provide nutrition to the plant receives nutrition-rich water that negates many of the behavior that accompany soil-based methods. Traditional Asian agriculture involves manual labor, much older than modern methods. Farmers depend heavily on the climate and weather. In traditional agriculture system, farmers have to monitor the condition of their field hourly and minutely to control irrigations. The project is applied in the agriculture sector of the country. The private sector can retrieve irrigation data for the specific regions and use it to ensure fair irrigation in the agriculture sector. My future work is another goal of this project is to improve the application by adding in the necessary features. It also can be designed to identify the specific plant disease and recommend appropriate treatment. Similarly, if the system is designed to communicate via satellite to nearest weather station, it can accurately predict the weather.
Good afternoon and selamat sejahtera to my panels and my lecturer and SB. Today I'm going to explain about my hydroponic project here. First of all, I want to introduce my component which I used for the project. This is our project board. This one will be our Node MCU with Wi-Fi module. This one is a microprocessor for our project. This one will be our LED display. The display will be here. This one will be our light sensor. It will detect the light intensity for our project. This one will be our water pump. So water pump got two valves here. One valve for the tank and one valve for our hydroponic solution here. So this one will be our ultrasonic. It will detect the level of solutions in the hydroponic here. So this one is a temperature sensor. This temperature sensor will detect the temperature of the solution to make it stable here. So this is our the place where we put our plant here. So this is the thing, the place where we put the plant. So here, this place where the solution, our hydroponic solution will accumulate here to support the plant. First of all, I want to introduce the app, Link app. So this app acts as IoT platform to control our smart farming system. Okay, this is the inner components of this. So first of all, this is for water pump. This one we can on, and then this section will be off for the water pump. So whenever we have to regulate the water into the water pump or to the hydroponic solution, we have to, after we receive the notification that we are shortage of water in the solution, so we have to press this to regulate the water from the tank to the solution, to the hydroponic solution. This one is the temperature. So this temperature they will read if above 26 or 27, that will be detect and give signal and send notification to this app. This one is ultrasonic sensor. Ultrasonic sensor there will be as plus minus 7 cm. So if the solution is below 7 cm, they will give a notification through the Blink app. So this one is a light intensity just now. So light intensity, so if there's no light, then it will show this intensity 1, it will show the 0. If the correct light intensity travel there, it will show 1. Okay, now I want to show the demo of our hydroponic solution now. You see, it is not connected. So now I already on my hotspot here, then connected to this device. So the connecting device already connected to our project here. You see, it's connected. So you show the temperature, all the detection, the light, and then the ultrasonic, all will be shown in our display here. So now I'll show one by one how to control our hydroponic now. Okay. First of all, you see, this one is the light. So I put the flashlight here, so it will stop. You see, I put flashlight here, it will stop. So now this one is our ultrasonic to measure the level of water. So for example, I put my hand here to detect the level. So it's already detected. See, it's already detected. So both are detected now. So no sound. There will be no caution portion for our solution now, because the light already give the light, and then the level of ultrasonic we already put the certain level there, so there's a no sound here. So the third thing, we have to do the temperature. We have to do the temperature sensor. Okay, this is our temperature. So now all the sensors now already occupied now. So we have to, this sensor, if our temperature more than 26, they will give notification to our device. So now it's not more than 26, so that's why it's a no alert alarm call there. So we have to give the temperature to make it, to show that it's more than 26. So our normally human temperature will be 36 or 37. So I think it's good enough. Okay, you see the sound there? So the sound is from the temperature, because it's already more than 26. So if I show the LCD display, you can see it show that T equals to 34, 35 like that. So it's more than 27, 26 already. So the sensor will give alert to us. This is how our sensors are working in our hydroponic solution now. Okay, now I want to explain and to show how the water pump functioning. They will regulate the water from the tank and go to our function. So now you see we already fill the water inside our water tank. So okay, now you see there's no light present, because you see no light here, there's no light here, so that's why they're giving the no light present. So these are also, you see, because just now as I mentioned, 7 centimeter is their distance, so the water level is low, so they will give the notifications like this level of hydroponic solution is low. So as obstacles, as we assume that our water level until here, so these hydroponic solutions notification will be stopped. It assumes that the waters are in correct measure, but the light is still the same, that's why we can hear the sound. So now they say that no water shortage in our system, so we have to press on. Okay, you see here the water are regulated from the tank, and then it's pouring into our system. So this is the way we absorb the water from the tank and pour into the system by pressing the on and off button. Now we can off it. You see, when we off it, it will stop pouring water from the tank. So this will be our plant. So our plant here. So until we know the level of solution is completed and level of is correct, we can stop the water pump. So okay, as you know, the sound is from this, so we can stop the sound here. You see, so there's no sound from the light intensity and also the ultrasonic, because the level of water, we assume that this is an obstacle, so we just put the hand as the obstacle. We assume that the water is level there below the 7, so it's no sound. The system are now completed. So after the level of water inside our system is low, the same thing, they'll give notification to the Blink app. Through Blink app, whenever we are in office, we are in the outside in our stations, we can control by the Wi-Fi or data using a Wi-Fi internet connection. We can control the water pump, the water all from our phone.